Okay, today we are going to talk about the atom. Now, we are not going to talk a great deal about the atom right now because, quite honestly, there's only a certain part of the atom that we talk about throughout chemistry until we get towards the end of the year, and those are the electrons. So the part that we care about are the electrons. But before we talk about the electrons, let's talk a little bit about the history of the atom. So we're going to start off with John Dalton. And John Dalton basically was the one who proposed the cannonball model of the atom, which basically said that building molecules was sort of like stacking cannonballs on top of each other. That basically, it's like sticking bowling balls on top of each other. They just fit together perfectly, and they stack like bowling balls. Now, another person came along called J.J. Thomson. And J.J. Thomson was messing around with a cathode ray tube. Now, what a cathode ray tube is basically there's a negative plate, there's a positive plate, and there's another negative plate here, and another positive plate here. You put electricity through it, and you get a stream of light. Now, this beam of light, when you have only this plate charged, and this plate charge goes straight across, and it looks like a beam of light. However, J.J. Thomson had decided to put in two additional plates. So when he turned on the additional plates, what happened was the beam started heading towards the positive side. And the conclusion was that this beam is composed of negative particles. And we call those negative particles electrons. And the reason why it was called electrons was not decided until much later, but it was basically based upon the idea that you'd put electricity through something and it would head to the positive side. Hence, he believed now that since the atom was not negatively charged, for every positive charge, there had to be a negative charge. And therefore, J.J. Thomson believed that that was what the atom looked like. Now, another man came along called Ernest Rutherford. And Ernest Rutherford basically shot helium at a piece of gold. So why did he do this? Well, he just thought it would be cool, and he thought he could possibly use this to electroplate, which means put gold onto various things, and to basically make gold coverings on iron necklaces, which would let the poor own gold-looking necklaces, all of what they have now. But what he got back, which was very, very surprising, was some of the helium he shot in bounced back. Now, the vast majority of it went straight through, as he expected, but the part that bounced back surprised him. And so he decided that the ones that went straight through meant that the atom was mostly empty space, but there was a nucleus. Why did I misspell nucleus? Yeah. there was a nucleus in the center which was very dense. And so now, unlike Thomson's method, he believed that there was a positive, negative center and lots of space on the outside. However, he realized that that couldn't possibly be. That was his first thinking. But he realized that the bouncing back would not occur unless there was some kind of charge that sent it back. So he decided that unlike Thomson's method, where it would have been a positive center, positive and negative center in the center with lots of space, there had to be a positive center with some negative stuff out here, but unknown where. It had to be out there. Finally, a guy named Bohr came along and told us that there was a positive center and that there are fixed orbitals in which we find electrons. And that is what you are taught in high school. The reality is that Ernest Rutherford was actually more correct. And that is actually closer to what we believe the atom to look like now. However, he was also partially incorrect because he believed that the negatively charged stuff could be anywhere. We now believe that there are these things called orbitals. It's sort of like a jawbreaker. So 2 electrons are most likely found in that area. Going out one more, we would expect 8 electrons to be in this area. You keep going out with an expectation. We don't know exactly where they are, but we know that they're, with 90% certainty, going to be found in the area that they're supposed to be found in. So what do you need to know about the atom? Well, basically you need to know this. There is a positive center, but also some neutral stuff in there. And there are electrons on the outside. And so the easiest way to think about this is that there are these things called orbitals, which we talked about here. These orbitals are where electrons are most likely to be found. And the outermost shell, just like in a jawbreaker, unless you break it open, the only thing anything sees is that outermost shell. We call this outermost shell the valence shell, just like a jawbreaker, and the only thing that reactions see is the valence shell. So let's take a look at an element like potassium. Now, potassium has an atomic number of 19, which means it has 19 positive ions, also known as protons, and it has 19 negatives, also known as electrons. Now, potassium has 19 electrons. However, if you go to the periodic table, we discover that it is in column number 1. And so that tells us it has 1 valence electron. And so the only thing we care about are the valence electrons. So while it has 19 electrons, the only one we are going to talk about in chemistry until towards the end of the year is the one that is on the outermost shell.